I'll
Absolutely.
do the slides.
Yes.
Okay.
Oh,
Well, thank you very much uh, for inviting me, and I'm impressed by the presentations. The good news is that I'm not going to have any formulas. The bad news is that the solution is up to you. Um, so the topic is innovative concrete solutions. And as you can see here, the state of Maine is doing an offshore wind farm. They just got a $200 million grant from a German utility called RWE. We're over here in Boston, and we could do, I think, a better project. The better project would look like this, a spar buoy instead of a semi-submersible. We have the electrical engineers who could do the interconnect, and we also have a nuclear engineering that could do a small modular reactor. You heard about these issues of interconnecting renewables with a grid and what the stability problems are. So let's look at the technology. This is the technology for offshore wind. The people at the University of Maine are doing this, which is called a semi-submersible floater. What we are proposing is a spar buoy, which is similar to this. The reason we're going with the spar buoy is because one of the things you have is the rocking constant of the wind turbine. You want to keep the tower top accelerations less than 0.3 Gs, and you want to keep the tilt less than 3 degrees. Well, we think that we could do this based on talking with marine architects. The other beauty of this solution is that we can design this and build it using American parts, concrete, etc. And we can install it using a Jones Act compliant vessel. Let me show you how this can be done. This was the wind turbine that MIT designed back in 1920. No, I'm sorry, 1940. This is the Palmer-Putnam turbine. It's a two-bladed downwind turbine, 1.5 megawatts. And it ran for about 700 hours before the blade fell off. The reason the blade fell off is because it's a downwind turbine and the blade is subject to the tower shadow, one per rev. What NASA did was after this, they turned it around so it's an upwind turbine. This is what the current technology is, an upwind turbine. The other thing that happened is instead of a two-bladed turbine, they made it a three-bladed turbine because the three-bladed turbine is aerodynamically balanced. The two-bladed turbine is not. That's why you have this teetered hinge, just like a helicopter. Okay, so this is what the proposed solution is. It's a concept, so you guys have to work out the details. But here's what the spar buoy would look like. We have a concrete tower and a concrete spar buoy so that it's corrosion resistant. And we think that we could actually do this with a Jones Act compliant vessel. And we also think that we could have a very simple and robust anchoring system as opposed to having a lot of cables. So then we go over to here, see what the state of the art is. Okay, this is the University of Maine. They have a $100 million offshore project funded by RWE and Mitsubishi. They call it the NASA turbine. If you're interested, I can send you the specs. As I said, it's a semi-submersible floater. What that means is if you have a large wave, it's susceptible to the wave because the wave is going to excite the foundation. When you go to a spar buoy, you miss the wave because most of the weight is down here. So it's a more stable solution. I know this because this is what the Norwegians are doing. They have a system, the Tampen project, up in the North Sea for their offshore oil platforms. And they're using this system instead of that system. So the challenge to MIT is, can you make this work? Can you come up with a better mousetrap than the current technology? Okay, in the next slide here, if I can get to the next slide. Okay, this is what the spar buoy looks like, the current spar buoy that's made out of steel. And the way that you can put the turbine up is you need a very large offshore crane. Well, these things are not available for the current turbine. The current turbine this is a 3 megawatt turbine, and the current turbine is 15 to 20 megawatts. The NREL turbine is 15 megawatts. So we don't have an offshore crane that's able to lift the NREL turbine and install it. We need a better mousetrap. Also, when you look at the steel spar buoy, it's going to be corrosion subject to corrosion. So we need a better mousetrap than that. And lastly, we think we need a concrete tower that telescopes into the spar buoy so that you can install it. So I told you I'm not going to show you formulas because you guys are better at this than I am. We have a naval architecture department at MIT. We have a nuclear engineering department. We have a mechanical engineering department. And we have young students who could figure all this out, as you've seen in the previous presentations. Here's what the potential solution could look like. We could have a Jones Act compliant installation vessel that would install the spar buoy and the turbine without having major port improvements. That's one of the issues, is how are you going to work in a port using this technology when the ports are already busy handling cargo. The other part of it, the other innovative part, is using ceramic composite spar buoy. Here in Denmark, they did these oil gas platforms using ceramic, well, not ceramic, this is conventional Portland cement foundations. And they had to make the cement at least 10 inches thick because the steel rebar inside would corrode. So we want to get away from that. What we want to do is we want to develop a geopolymer construction that's stronger than the Portland cement. This is a study that was done by the Oklahoma State University, and I'm hoping that the MIT Material Sciences can come up with this. So the concept is a geopolymer cement with basalt fibers. The basalt is the reinforcing bar instead of the steel rebar, because basalt is not corrosive. And the basalt and geopolymer form a strong chemical bond, so you can meet a 100-year service life. The other beauty of this is that you can install the spar buoy using the Jones Act compliant vessel. You can install it with the same vessel. Okay, so what would the solution look like? Well, as we said before, you could use existing ports, because the turbine would be made in the U.S. and you load it up on top of your installation vessel, and you take it out to the site, and then you pour the geopolymer cement, and you install the concrete towers, and you install them with the vessel, and you end up with a clean solution like this. This is what the Tampen project would look like in Norway that they're working on. So the question is, what's the next step? Well, you guys are the experts. We need opportunity-ready projects. We need projects that we can give to our kids and grandchildren. We need the technology and integrated turbine foundation design that leapfrogs the existing technology or is better than the existing technology. Then you need the utilities to seek power purchase agreements. Once you have the technology, then you can attract financing. And lastly, you need public support. And here in California, we have rolling blackouts, and we have rolling blackouts and drought. So we need power, and we need renewable power. And perhaps with your technology and innovativeness, you can make that happen. So the future is up to you, and I'd like to help you. If you have any questions, if you need references, you've got my information, and I'd love to be part of the solution. Thank you for your interest. Do you have any questions?
Hi, thanks. Andy, thanks for your nice presentation. And just wondering, any questions from our audience? I think I saw a question from Alexander.
Yeah, can people hear me?
Yeah.
Oh, hi, Andy. I know you've emailed me a bunch in the past and about topics, so it's nice to see your face in this really excellent presentation, by the way.
Thank you.
On all these spar buoy concepts, I think I definitely agree with if there's a way to either use like a suction anchor, that's another option for anchoring into the mud. I think it'll depend upon the geology that's down there as to if we can get into it. But if it's mud, suction anchors are definitely a thing to think about also.
Agreed.
So that may be something to consider. As far as like a non-concrete, because you're worried about corrosion, has not the coated rebar pretty much solved the problem of rebar in concrete in saltwater environments, you know, where they put the epoxy coating on the rebar?
I don't know, Alexander. I think you're the expert. Here in California, if you build bridges or any structures that have salt water, you have to do at least 10 inches over it, even if you have rebar that's coated. So maybe the codes are different here in Massachusetts, but part of the reason we want to do concrete is not so much, well, corrosion resistance is important, but the other one is because we want to have it made locally. And we have a lot of concrete technology in the US. And we have the ability to source that. So instead of buying the turbines overseas, we should make them here. The turbines that are used, these offshore wind turbines, are typically 3-inch steel. And we don't have many places in the US that can pour and bend 3 inches of steel. We have a lot of places that.
Okay, so I think what's going to be happening very soon is this will all be solved, and I can't tell you why, but some inside information, I'm pretty sure this will be addressed. So in other words, that's a good saying. I think that there just has to be the market pull for people to say, all right, this is what we want to do.
Exactly.
You can email me, or whoever's interested, email me separately on that. Okay, that's all I had. But good, very good presentation. Very, very much liked it. Thank you.
Thank you, Alexander. The one question is, here in California, we have these offshore wind leases that are going to be put out for bid. And right now, there's only one American company that has the offshore wind leases. All of the offshore wind leases are held by European companies. So I would be very interested if we could put together an American team to tender these offshore wind leases. I used to work for P&E Wind, and we tendered the Atlantic offshore leases. And when the lease price went above $200 million, we dropped out. I'd like to see an American company tender the offshore wind leases and build an American project.
Yeah, I have no clue what's happening in that realm. You know, GE is an American company, but their big offshore turbines are all made in Europe. I think that was because of an acquisition.
Exactly. They purchased Alstom, and the GE turbines are made in Alstom. I used to work for GE, and when you go to Schenectady, it's a ghost town because GE's manufacturing is all shipped off seas or overseas or wherever. So yeah, I would love to work with GE to tender the offshore wind leases and use GE turbines made in the US.
I guess if we could buy half Mitsubishi and half GE, that kind of averages out to the US. So
there you go. There you go. Whatever works. But let's have American jobs. Let's have jobs for our kids and our grandkids. And let's have a US center of excellence. Come on. I mean, we should be able to do this.
So the interesting thing I would think would be that we'll have to see Because I remember in your neck of the woods in the LA area, Atlantic Richfield at the time, and had a huge R&D facility where they were doing design work for the Arctic. So I'm just thinking of places that were working on really big iron, right? Because for Arctic, everything was made in modules, like in Seattle area. And so if you look in the shipyards, San Francisco, Puget Sound, and even in San Diego, the big naval yards, that would be the place to try to organize this. In particular, if leases were around San Francisco, so the city of San Francisco is trying very hard to figure out what to do with the old Navy base. So why don't we talk offline? I have no clue if it's possible or not. And then
Okay, can you send me your, I'll give you a call, Alexander. And a point in fact is that here in California, we have these offshore oil platforms. They're actually one of the best places to go fishing, right in LA Basin. You fish off the oil platforms because the fish like to congregate there.
Yep,
And
I've dove up them.
Right, and so it turns out we have these oil platforms off Gaviota, the Exxon oil platforms, and they could put in offshore wind turbines because it's already a disturbed site. And that's what the Norwegians are doing. The Tampen project in Norway is an oil gas field, and they want to put in wind turbines so they don't use up all the oil to power the platforms. So if you have any suggestions, and if you can help me put together a team to do this, I'm all here for you.
Yeah. Okay. I just sent you an email to ping you. I leave tomorrow. I'm back the 20th, so then we'll talk more then.
Excellent. Thank you, Alexander.
Okay.
I appreciate your insight.
Okay.
Thank you, guys.
Yeah, thanks, Andrew, for your very nice talk, and also I also enjoyed the discussion between you and Alexander. But I guess we have other question from Graham, but the time is kind of overrun. Probably you can just do a direct message between you and Graham. We